Welcome friends, welcome to Cool Monk, and today's topic of the video is Tower of Hanoi. It's a very famous problem and it's asked in interviews many times, and today we'll discuss the same. We'll understand, we'll devise a algorithm to solving it, and then we'll write a proper code to solve it. Okay, so I found this problem in the practice session of the Geek for Geeks, and let's start. So first we'll understand the problem, and then we will uh, try to solve it. Okay. So okay. So Tower of Hanoi is a famous puzzle where we have three rods. So we've got a first marker. We have a three rod and n discs. Okay. The object of the puzzle is to move the entire stack. So discs are arranged in stack. Your given number of discs is n. Okay. Initially these discs are on rod 1. Okay. And then you need to print all the steps to move the discs so that the disc reach the third rod. Okay, so there's some constraints associated with this problem. What are the constraints? So when the problem starts, the discs are stacked one on top of the other, and in this stack all the discs are arranged from uh, in such a way that the lowest value of the disk 1 being lowest and n being the highest, disk 1 is on the top and disk number n is in the bottom. Okay, and while moving the disks, okay, you cannot place any disk on top of a disk which is having a value lower than the disk itself. Okay, so you cannot place a disk of size 2 on top of a disk of size 1. Okay, but the other way around, placing a disk of size 1 on top of 2 is possible. Okay, so let's see how the Tower of Hanoi looks. Okay, so basically this is the first rod, this is second rod, this is the third rod. Okay, first rod is called 1, 2 and 3. Okay, and for now there are n number of discs. We'll consider that we have 3 discs. Okay, so this is disk number 1, this is disk number 2 and this is disk number 3. Okay, this is the starting point. Okay, 1, 2, 3. And what is our target to move this disk? 1, 2, 3. Okay, and this is the auxiliary disk which can be used to stage some of the disks while moving. Okay, so basically how can we solve this? Okay, so what we can do is we can say that I don't know to move n number of disks, here 3 disks, so I don't know how to move 3 disks, but I know if I can move the first 2 disks from here to this auxiliary disk, then I can move this third disk from here to here. Okay, and then once this is done, I can move these 2 disks which were here from here to this final location. So this is possible. So we'll assume that we have the algo to move n minus 1 disk. Okay, let's see. So we'll copy this driver code and we'll place it in Eclipse, which I've done already. Okay, so this is how it should print. Okay, and then it should also print the number of moves it took. Okay, so let's see how we can solve this. Okay, so what we can do is, so this method is being called to move n disks from rod to rod using auxiliary rod. Okay, so what was the first step that we'll do? Move n minus 1 disk to aux. So for doing that, I will call the same method, but instead of passing n, I will pass n minus 1, and I want to move from to auxiliary. Okay, so okay, and what is the auxiliary for this movement? 2. Okay, now what we do? Now we will have to do the movement of the nth disk. Okay, so let me see how is the pattern. So this is what should be printed. I'll do sys out and I'll print this. Okay, so are we moving this one? No, we are moving the nth disk. We'll change this. Okay, and we are moving it from rod 1. Okay, and what is rod 1? Rod 1 is from. Okay, and where we want to move it? To the 2 disk. Okay, once this is done, we want to move this n minus 1 disks, which are for now these disks were on the second rod. We want to move it onto the third rod. So what is the source? Source is the auxiliary rod. Where we want to go? To the target. And what is the auxiliary rod we'll use here? From. Okay, so this should be doing the trick. But if you see, if we call this method, it will continuously call itself, and then it will be stuck in infinite loop. It will stack. So there should be some terminating condition. Okay, so n is decreasing each time. So if n was called with 3, the next time it will be called with 2, and then the next time it will be called with n is equal to 1. But we know for sure if there's only one disk, then what do? Then we just move the disks from source to target. We'll check for the condition that if n equals 1, then we want to do something. What do we want to do? We want to move that desk from source to target. Okay. So move desk n. So if n is equal to 1, it will say 1 from rod this from to target 2, which is good. Okay. But if n is not 1, then only we want to execute the rest of the part. Okay. So all this will go in else. Okay. But there's a problem. It's showing compilation error because it wants to return long, and what this long value is the move count, the number of move. So instead of returning this from each call, what I could do is, okay, so it's called here, okay, Tower of Hanoi. So what I could do is I could create one more method, okay, and this will be Tower of Hanoi recursive, and this one would be Tower of Hanoi, okay, and I will call Tower of Hanoi recursive here, okay, and Tower of Hanoi is void. I don't want to return anything. Now how do we count move? To count move, we will create a reference variable private integer moves, and the count will be 0 before any movement. Okay, so we can, once this is done, we can return moves. Okay, but hold on, this move this moves would be 0, so we'll have to increment whenever a movement is done. So where the movement is being done, movement is being done here and here. Okay, so we'll do increment the move here. Okay, and we'll also increment the move here. Okay, and then yeah, this should work. Let's see what happens. Let me just copy just the logic. So replace this. Let me compile. Okay, looks good. Let me submit and see if it runs. Yep. So that was all. I will provide the link of the problem as well as the link to the GitHub uh, code link. So that was all for today's video, and I'll be back with another problem, another nice discussion. Thank you.